So in this practical, you have to determine the concentration of sodium carbonate as well as sodium bicarbonate in a given solution pH metrically, right? So in a mixture, you would be having two things. One would be sodium carbonate, another would be sodium bicarbonate, right? Sodium carbonate is a washing soda, whereas sodium bicarbonate is a baking soda, right? So you have to find out the concentration of both of this using a pH meter. So requirement is you require X normal Na2CO3, X normal NaHCO3, then you require standard 0.1 normal HCl as a titrant. Okay, then you require the electrodes, beaker, glass rod. Okay, so over here you will be titrating the mixture against standard 0.1 normal HCl. So it's an acid-base titration, right? So wherein the neutralization reaction would occur and both of this thing would get neutralized. And in this practical, you will be getting two endpoints, okay? And you have to find out the normality of both of this as well as you have to find out the concentration in gram per liter. So first of all, suppose say if the solution is being given to you in either 100 ml or 250 ml of volumetric flask, you have to make up to the mark, and from that volumetric flask you have to take 50 ml of the solution in a beaker for the titration against 0.1 normal HCl. So over here also you have to go for both the sets. First set would be the pilot set and the second set would be the micro set, which is being carried out in order to find out the exact endpoints. So using both the sets, you have to draw two different graphs. From the first set, that is the pilot set, you have to draw a graph of pH versus volume of HCl which is being added. Whereas from the second set, you have to draw a graph of delta pH upon delta V versus the volume of the HCl. So everything would be similar to that of the previous practical, that is of aspirin. Okay, in that practical you are getting only one endpoint. Over here you will be getting two endpoints because over here there are two different components which are there in the sample which are to be determined. So let us start first of all with the pilot set. Okay, so we know that Na2CO3 and NaHCO3 both are basic in nature, right? So initially when you determine the pH of the sample solution, okay, when no HCl is being added, the pH would be alkaline. Okay, it is pH is 9.62. Now this is the graph of pH versus the volume of the titrant, okay, which is HCl. So we are adding protons, or you can say hydrogen ions, we are adding to the beaker. Okay, so initially when HCl has not been added, the pH would be alkaline, right? It would be basic. And our sample is having two things, Na2CO3 as well as NaHCO3. Now, if I talk about the pH of Na2CO3, then it would be around 11. Whereas the pH of NaHCO3 is around 8.3, right? So, based upon the pH, we can say that Na2CO3 is more basic as compared to NaHCO3. Okay, and we are taking strong acid as a titrant. So, more basic Na2CO3 would be titrated first against HCl and it would get neutralized first, and then the NaHCO3 would get neutralized. Okay, over here you can see that CO3 2 minus would be there. Over here HCO3 minus would be there, right? So the negative charge would be more over here as compared to here. Okay, so that's why the affinity of H plus ions towards CO3 2 minus would be more as compared to HCO3 minus. So that is the another reason why the neutralization of Na2CO3 takes place first. Okay, so what will happen when you add HCl into it, into the beaker? The pH would start decreasing, right? It would decrease slowly, and during this reaction what will happen, H plus ions which are being added will react with CO3 2 minus. Okay, so over here the HCl we are adding, so HCl will react with Na2CO3. Okay, so H plus ions will be reacting with CO3 2 minus, and it would get converted into HCO3 minus, that is NaHCO3, okay, plus NaCl. Okay, so you can see that over here Na2CO3 has been neutralized to NaHCO3. Okay, so we can say that over here half neutralization of Na2CO3 is being taking place, right? Because it is not getting converted into H2O2 and CO2 directly. Okay, so over here what will happen? When you keep on adding the HCl, this Na2CO3 would get converted into NaHCO3. And when all the Na2CO3 has been converted into NaHCO3, the pH would drop. Okay, and you will be getting the end point. Your end point would be somewhere here, right? So when all of the CO3 2 minus has been reacted with H plus ions and has been converted into HCO3 minus, the pH would drop. Okay, after that HCO3 minus would react with H plus ions. Okay, because we will keep on adding the HCl. So HCO3 minus which is there will react with H plus ions to give H2CO3, which would be further converted into H2O plus CO2. Okay, so that is this reaction. NaHCO3 will react with HCl to give you H2O plus CO2 plus NaCl. Now this NaHCO3 over here would be of two types. One would be the NaHCO3 which has been obtained due to the half neutralization of Na2CO3, and another type of NaHCO3 would be the NaHCO3 which is already there in the sample, right? Again I am repeating, NaHCO3 would be of two types. The first one would be the NaOH which has been obtained due to the half neutralization of Na2CO3. And another type of NaHCO3 would be the amount which you have already taken as your sample. Okay, because initially we take the sample of Na2CO3 plus NaHCO3. So both the types of NaHCO3 will be reacting with HCl to give you H2O plus CO2. Okay, and when all of the NaHCO3 has been neutralized, the pH will again drop. Okay, so over here you will be getting your second endpoint. Okay, and then when you keep on adding the HCl, the pH would drop gradually. So in this way, this would be the nature of the graph which you will be getting. So these are the correct readings. Okay, now in this practical, what you can do is you have to add either 0.55 ml of HCl and you have to determine the pH value, or you can add 1 ml of the HCl and you can determine the pH value. Okay, it's up to you. Then you need to determine the delta pH. For the first reading there would be no delta pH. Okay, for the second one 9.48 minus 9.62, it would give you 0.14, and in a similar manner you have to find out the delta pH values. So over here you will be getting the two equivalence point. At the first equivalence point, half neutralization of the Na2CO3 would occur, and at the second neutralization reaction, NaHCO3 which has been obtained over here would get neutralized, as well as the NaOH which is already present in the sample would get neutralized. Okay, so if we see the delta pH values, then the maximum delta pH value is being obtained to be 0.75, and it has been obtained at 3 ml, right? So you have to take the reading between 2 to 3 ml. Okay, and if we see further, then maximum is obtained at 1.65. Okay, so there is a major difference in the pH between this two. So for this case you will be taking the readings between 9 to 10. Okay, so in the microset you can see that the readings are being taken between 2 to 3 ml as well as 9 to 10 ml. Okay, now this graph is this one. Okay, if you draw it, it would look like this. Over here that would be the first in end point. Over here you will be obtaining the second end point. Okay, so now let us move on to the microset. Okay, so for the microset you need to determine the pH. First of all, you will be taking the 50 ml of the sample in a beaker, start adding HCl, determine the pH, right? So you can, over here you can see that 1 ml is being added initially. You can add 0.5 ml also, and you can take the reading. Then from the 2 to 3 ml you have to add 0.11 ml of the HCl, and you have to take the reading. Then again add 1 ml or 0.55 ml, and from 9 to 10 again you have to take the reading by the addition of 0.1 ml of HCl, right? So you have to write down the pH value, determine delta pH, delta V, delta pH upon delta V. Then you have to draw a graph of delta pH upon delta V versus the volume of the HCl which is being added. So in this you will be getting the two peaks, right? So now let us see where the maximum has been occurred, right? Where maximum delta pH upon delta V has been obtained. So over here we have to see between 2.1 to 3. Okay, so maximum is this one 0.52, and it has been obtained at 2.9 ml, right? So our first equivalence point is 2.9 ml, that is V1. Now then you have to check between 9 to 10. Okay, so the maximum delta pH upon delta V is obtained to be 1.06, and it is at 9.7 ml. So your V2 would be 9.7 ml. So you got two endpoints, right? And when you draw a graph of delta pH upon delta V versus HCl, you will be getting a graph like this, okay, wherein you will be getting two peaks. And if you draw a straight line from here, then you will be getting V1 and V2, that is these two values. So in this way, from the graph also you can check what is V1 and V2, and from the table also you can get to know that what would be V1 and V2, that are your endpoints, right? Now, if we see this reaction, then Na2CO3 is being neutralized only half, right? So at the first equivalence point, there would be half neutralization of Na2CO3, right? So H plus will react with CO3 2 minus to give HCO3 minus. So there is half neutralization. So V1 is the volume of the HCl which is required for the half neutralization of Na2CO3. Okay, so 2V1 would be the amount of the HCl which is required for the complete neutralization of Na2CO3, right? Because if V1 is the ml of the HCl which is required for the half neutralization, then V1 into 2. If you take V1 two times, then that much amount of the HCl would be required for the complete neutralization of Na2CO3, right? So you have to take 2V1, that would be 2.9 into 2, which would give you 5.8 ml, and using this value you have to find out the concentration and normality of Na2CO3. Okay, in this graph you can see that this much is the V1, okay, and V2 would be up till here. Okay, this region includes HCO3 minus, which has been obtained over here, and HCO3 minus, which is already there in the sample. So suppose say this is the V1, okay, and this portion, then it would be V2 minus 2V1. Okay, so for the first one, Na2CO3, the things are clear. We have to take 2V1. Okay, now let us see that how NaHCO3 would be determined. We know that at the second equivalence point, or you can say end point, the amount of the NaHCO3 which is being obtained to do half neutralization, as well as the amount of NaHCO3 which is already there in the sample, would get neutralized. Okay, so that reading would be V2. So distance from, or you can say volume from starting up till here would be considered to be as a V2. So from that you need to minus out the value of the HCl which is being required for the neutralization of Na2CO3. So you have to minus out that to V1 from the V2, right? So we know that 2V1 is the amount of the HCl which is being required for the neutralization of Na2CO3. So minus that out from the V1. So V2 minus 2V1 will give you this answer, that is 9.3 ml, and that could be used for the determination of NaHCO3. So in the result section, you can see that 50 ml x normal diluted Na2CO3 required 2v1 ml of 0.5 normal NaOH. So over here you have to write down 5.8 ml. Then you have to find out the normality. For that, N1V1 equals to N2V2 can be used. Okay, so the same method can be used. Okay, wherein you will be taking 2v1, okay, and you have to do the calculation. And amount of Na2CO3 in equals to gram per liter, you also have to determine. For that, you require the equivalent weight of Na2CO3 and you can determine it in gram per liter. Then for NaHCO3, the 50 ml of the diluted NaHCO3 required V2 minus 2V1 ml of 0.5 normal HCl. Over here by mistake NaOH is being written, it would be HCl. Okay, we know that 2v1 is the amount which is required for Na2CO3. So from the total we have to minus out the amount which is required for carbonate in order to get the bicarbonate amount. Then you have to find out the normality, wherein you will be using this value, that is 3.9 ml for the calculation. Okay, and then you have to finally find out the amount in gram per liter. Okay, so over here we have taken a mixture of two different base, and we have taken standard acid, okay, and it's a normal acid base titration, okay, wherein first of all Na2CO3 would get half neutralized and the first equivalence point would be obtained. Okay, so if you want to find out the total amount of HCl which is required for the neutralization of Na2CO3, then it would be 2v1, that would be v1 into v1. Okay, and later on NaHCO3 which is being obtained due to half neutralization of Na2CO3 plus the amount of the NaHCO3 which is already there in the sample, both will get neutralized to H2O2 and CO2, right, and you will be getting the second equivalence point. So from the total amount of the titrate, you have to minus out 2v1, that is for Na2CO3 neutralization, in order to get the amount of the NaOH, NaHCO3 which is there in the sample.